Bismillahirrahmanirrahim. Assalamu alaikum. In this lecture, we shall study the Cauchy-Euler equations. They are also called the Cauchy-Euler equation or Euler equations. Let us see the definition. We say that an equation of the form 1 is called the Cauchy-Euler equation. Here the coefficients a n minus 1 up to a1 comma a0 are real numbers. And we can see that in each term, the order of derivative and power of the variable is same. That is why these type of equations are also called equidimensional equations. Let us see some examples. In example 1, this is first order Cauchy-Euler equation, and we can see in the first term order of derivative is 1, so power of x is also 1. Look at the second equation. This is second order Cauchy-Euler equation. And here the order of derivative in the first term is 2, so power of variable is also 2. In the second term, order of derivative is 1, so power of x is also 1. Similarly, in the third example, which is third order Cauchy-Euler equation, the order of derivative in the first term is 3, so power of variable which is multiplied with this is also 3. In the second term, order of derivative is 2, so power of variable is also 2. In the third term, order of derivative is 1, so the power of variable is also 1. So these type of equations are called the Cauchy-Euler equations. Method of solution. Let us remember some notations. We shall denote d by dx by capital D, d square by dx square by capital D square, and so on. D by dt is denoted by delta, and we denote d square over dt square by delta square, and so on. If we are given a Cauchy-Euler equation, the first step is that put x is equal to e power t. And from here, we can easily obtain that t is equal to log of x. Now, put xd is equal to delta. X square d square equal to delta into delta minus 1. X cube d cube equal to delta into delta minus 1 into delta minus 2, and so on. If we remember all these notations, we can easily transform the Cauchy-Euler equation to an ordinary differential equation with constant coefficients. And then we can easily solve that equation by using the methods of the previous lectures. Let us prove result number 2, 3, 4, and so on. From equation number star, by differentiating both sides with respect to x, we have dt over dx is equal to 1 over x. And now let us use the chain rule to get the value of dy by dx, which is equal to dy over dt into dt by dx. But we have already obtained the value of dt over dx. So we can write that this is dy over dt into 1 over x. So we have a result dy over dx is equal to 1 over x into dy over dt. Let us say this is result number A. Now from A we can obtain, multiplying both sides with x, that x dy over dx is equal to dy over dt. Let us use the above notations. So we have x capital dy is equal to delta y. And from this we can easily obtain that xd is equal to delta. And that is the proof of result number 2. Now let us prove result number 3. Again from equation A, differentiating both sides with respect to x, we have d square y over dx square, which is equal to d over dx of 1 over x into dy by dt. Let us apply the product rule. We write first function differentiation of the second function plus second function differentiation of the first function, which we can further simplify that d square y over dx square is equal to, we can write 1 over x, just replace d by dt and d by dx of y. So we write differentiation of 1 over x is minus 1 over x square dy over dt. And now from equation number A, we have the value of dy by dx. Let us put the value of that term. We have 1 over x into d by dt of 1 over x into dy over dt minus 1 over x square dy over dt. Now from here we can see that d square y over dx square is equal to 1 over x square into d square y over dt square minus 1 over x square dy over dt. Let us multiply x square on both sides. So we have x square d square over dx square of y is equal to d square y over dt square minus dy over dt. And now let us use our notations. So we have x square d square y is equal to delta square y minus delta y. And from this we can see that x square d square is equal to delta into delta minus 1. And that is the required result number 3. Similarly, we can prove result number 4 and so on. To solve question number 1, we can see that the order of derivative and power of the variable x in each term is same. So this is the Cauchy-Euler ordinary differential equation. This equation can also be written as x square d square minus 4xd plus 6 whole into y is equal to 24x power 5. Now let us put x is equal to e power t and xd is equal to delta. X square d square is equal to delta into delta minus 1. So we can obtain delta into delta minus 1 minus 4 delta plus 6 whole into y is equal to 24, and x power 5 can be written as e power 5t. Let us simplify this. So if we simplify, we get delta square minus delta minus 4 delta plus 6 whole into y is equal to 24 e power 5t. If we further simplify this, we can obtain delta square minus 5 delta plus 6 whole into y is equal to 24 e power 5t. Let us say this is our equation number A. And we can see this is an ordinary differential equation with constant coefficients. So we can use the method of UC to obtain YC and YP. To obtain YC, its auxiliary equation is given by this thing. And now let us factorize this. So we have delta square minus 3 delta minus 2 delta plus 6 is equal to 0. Taking delta as common, we have taking minus 2 common from here, and we can get this result. From here we can get delta minus 2 into delta minus 3 is equal to 0. So we have two roots. Delta is equal to 2 and 3. These are two different real roots, so the complementary function yc is equal to c1 e power 2t plus c2 e power 3t. And now let us use the UC method to obtain yp. So yp for this function is a e power 5t. Let us say this is our equation number B. Now let us differentiate this. So we have delta yp, which is equal to 5a e power 5t. And now let us differentiate it again. So we have delta square y, which is equal to 25a e power 5t. Now putting these values in equation A, we can obtain that the value of delta square, that is 25a e power 5t. Now minus 5, the value of delta y, so that is 5a e power 5t plus 6, the value of y, which is a e power 5t, and this is equal to 24 e power 5t. Let us simplify this. 5 5s are 25, so these two terms will cancel. So we have 6a e power 5t is equal to 24 e power 5t. Now let us compare the coefficient of e power 5t on both sides. So we have 6a is equal to 24, and from here we get a is equal to 4. Therefore, from B we can get the particular integral yp is equal to 4 e power 5t. And now the general solution, y is equal to yc plus yp. So let us put values. So we have y is equal to, the value of yc is c1 e power 2t plus c2 e power 3t. The value of yp is 4 e power 5t. Finally, let us replace the value of e power t, which is equal to x. So we have y is equal to c1 e power 2t is now equal to x square plus c2 e power 3t is equal to x cube plus 4 e power 5t is equal to x power 5, and that is the required solution of this problem. Question number 2. As we can see that the order of derivative and power of the variable are same in each term, like in this term order of derivative is 1, power of variable is 1. So this is the Cauchy-Euler ordinary differential equation. This equation can also be written in the form x square d square minus 2xd plus 2 whole into y is equal to log x. Now to solve this equation, we will put x is equal to e power t, and from here we can get that log x is equal to t. Similarly, we can put xd equal to delta, and x square d square is equal to delta into delta minus 1. And this equation will become delta into delta minus 1 minus 2 delta plus 2 whole into y is equal to log x is equal to t now. Let us simplify this. We get delta square minus delta minus 2 delta plus 2 whole into y is equal to t. And now if we further simplify this, we have delta square minus 3 delta plus 2 into y is equal to t. And we can see that this is an ordinary differential equation with constant coefficient. So we can solve this by the UC method. Let us find its auxiliary equation, which is delta square minus 3 delta plus 2 is equal to 0. Let us factorize this. Delta square minus 2 delta minus delta plus 2 is equal to 0. Taking delta is common, and from here taking 1 is common, we have this equation. From here we can get delta minus 1 into delta minus 2 is equal to 0. So we have two roots. Delta is equal to 1, comma 2. These are real and distinct roots. So yc, the complementary function, is equal to c1 e power t plus c2 e power 2t. And now let us find yp. So yp, as it is polynomial of order 1, so yp is equal to a plus bt. Let us differentiate this. Delta yp, this is equal to b. Now let us differentiate it again. We have delta square yp, which is equal to 0. Therefore, equation 1 becomes, from equation number 1, now we can also write equation 1 as delta square y minus 3 delta y plus 2 y is equal to t. So let us put values in this equation. Delta square y, that is 0, minus 3 delta y, that is b, plus 2y, the value of y is here. So we can put a plus bt is equal to t. And now if we simplify this, we have 2a minus 3b plus 2bt is equal to t. Now let us compare the coefficients on both sides. So on the left hand side, the constants are 2a minus 3b is equal to 0. And on the right hand side, we have 0. In the left hand side, the coefficient of t is 2b. On the right hand side, the coefficient of t is 1. So from here we get b is equal to 1 over 2. And now let us find the value of a from equation star. So we have 2a minus 3. The value of b is 1 over 2. So we write like this one. So it implies that b is equal to 3 by 4. Now let us put these values in 2. So 2 becomes yp is equal to a. Sorry, this one is a. A is 3 by 4 plus b is 1 over 2t. That is the required particular integral. And now the general solution y is equal to yc plus yp. Let us put values. We have c1 e power t plus c2 e power 2t. And the value of yp is 1 over 2t plus 3 by 4. And now let us re-put the values. So re-put x is equal to e power t and t is equal to ln x. So we have y is equal to c1x plus c2x square plus 1 over 2 t is equal to log x and plus 3 by 4. And that is the required solution of the given problem. That's all.